Objectives: solving rational equations and solving rational inequalities. Let's start by looking how to solve rational equations. So imagine that we want to solve this equation: 2 divided by x plus 3 plus 3 over 2 equals 90 over 10. So what do we want to do? The tip for solving is that when we want to solve a rational equation, we want to get rid of the fractions, and after that we will solve it as linear equations we did before, or possibly quadratic equation. So how to get rid of the fraction? Well, let's revise what is a least common denominator. Common denominator is the multiple of the denominators of a set of fractions. But in our case, we want to find the least, or also known as lowest common denominator, which is the lowest common multiple of denominators of a set of fractions. So what is that? So imagine that we have a easier example, 1/2 plus 2/3. And so what is the common denominator? As it said, it's a multiple of the denominators. So the multiple of the denominators is 2 times 3, that's 6. In this case, 6 is also the lowest common multiple of 2 and 3. So in this case, the common denominator and lowest common denominator is the same. Let's look at another example, 5 over 12 and plus 11 over 18. Well, in this case, the common denominator, again, the multiple of the denominators, is 12 times 18, 216. But is there a number that's smaller, so we don't have to then work with the big numbers when we are solving this problem, when we want to multiply the whole, for example, equation with the common denominator? Well, we can write down all the multiples of 12 and 18 and look if there is something similar, if there is the same number. And we can see that there is 36, same, and that's actually the lowest common denominator for 12 and 18. So that will be the best number to use to multiply. Let's now get back to the original problem. So we want to find the least common denominator. So here we have a kind of a separate part, x plus 3. It has the x, so let's put it on the side. So we are looking for a common denominator of 2 and 10. So if we multiply them, that's 20, but is there some other number that's divisible by both of them and it's lower than 20? And it is, it's actually the number 10. So the least common denominator would be 10 times x plus 3. So as we said before, now we take the least common denominator and multiply every term in the equation. So here we have it, each term multiplied by the term 10x plus 3. So what will happen now? Some things will cancel. So in the first one, for example, x plus 3 will cancel. It will end up with 2 times 10. In the second part, 3 over 2 cancel with 10, or 2 will cancel with 10. You'll be left with 5 over here. And in the last, on the right side, 10. 10 will cancel, we'll be left with 90 times x plus 3. So to the next step, we now want to distribute the parentheses. So we will get 15x plus 65 over here. 45 but plus 20, 65, and 19x plus 57. We want to move x's to one side, number to the other side, get minus x equals minus 8, and finally the answer by multiplying with, dividing with minus 4, we'll get x equals 2. What do we want to do now? We want to check that this is the right answer. So we want to take our x2 and check that this is the right answer. So what we have to check? We have to check that the left side equals the right side. So let's substitute with 2 for our x and see if it works. So when we do the check, we first do the left side. So we substitute with 2 over here, do the work, do some fraction addition, and we will get at the end, let me erase this, we get 19 over 10 over here. And what do we have on the right side? On the right side we have exactly 19 10 over 10. So left side equals the right side. and then check that our answer x equals 2 is correct. Let's look at one more example how to solve rational equations. This one is a little bit more complicated. So what we have to do first? Well, we again want to find the least common denominator. Here we can see that there's a little problem what to do with the quadratic equation over here. Well, what we want to do, we want to factor it out. We want to simplify it and see if it's maybe if it can help us. Well, how do we simplify it? You can simplify it to x plus 4 equal x minus 2. Here are the details how to do it. Remember that when we are factoring, we can use the number 2 and number minus 8, b and c to find the roots of our quadratic equation. Also, you can use a different method, like for example using the quadratic formula, if for example the factoring wouldn't work for you. Okay, now let's look at it. Well, now it's way easier to find the least common denominator. We can see that x plus 4 and x plus 4 repeats here, and x minus 2 and x minus 2 repeat over here. So we don't have to use all of them, but x plus 4 and x minus 2 is enough to beat our least common denominator. We don't have to repeat them. So again, as in the previous case, we multiply all parts of the equation with the least common denominator, and the denominators in each of the fractions will cancel. So at the end, we'll end up with x plus 4 equals 2x plus 1 plus 2 times x minus 2. And that's again linear equation that we just need to solve. So let's move all x's to the left side, all numbers to the right side, and we are getting that the answer is x equals 7 over 3. Again, we would want to check that we have the correct answer by substituting for x in the left side and the right side. Well, the left side is simple. It's just one fraction, so we are getting that the answer on the left side would be 3. When we substitute on the right side, there is a little bit more work necessary to do, but hopefully I did it all right, and I got to answer 3. Therefore, left and right side are the same, and our solution 7 over 3 should be correct. Here are some practice exercises for you that you can try right now. You can pause the video and try to solve them on a piece of paper, and then look for the solutions. The solutions will be showed on this screen in a few seconds, so please pause the video so you can solve it. Be careful about these quadratic terms here. Try to factor them out, and you can find easily the least common denominator. So let's look at the solutions. For the first one, we have least common denominator p minus 5 times p minus 4, and the answer is p equals 8. In a second one, we have a common denominator, least common denominator z plus 1, z minus 1, and we'll get to the solution that z equals 1. However, be careful, remember that denominator can never be 0, and if we substitute, if you then try to do the check at the end and you substitute 1 over here or 1 over here, you will get 0 in the denominator. Therefore, this practice exercise actually has no solution, since z cannot be equal minus 1 or 1.
Now, before we continue, please don't forget to like the video and subscribe to our channel. As a reminder, we offer private and group online math lessons on Zoom, where we cover all UAE National Curricula, American and British curriculums. We also have the best MSAT math test preparation course with a 50% discount for groups. The first session is always free. So if you are interested in a free lesson, click the link in the description below. To book a lesson, you can always send us a direct message on Instagram at Mr. Mathematics. Okay, with that said, let's get back to our lesson.
Moving to our second learning objective, solving rational inequalities. So we have here an inequality 4 over 3x plus 7 over x is less than 5 over 9. So how do we solve this rational inequality? We have 4 steps that we should follow to solve it. First step is to state the excluded values. They are the values for which the denominator is 0. Second, we'll then solve the related equation. So we change the inequality sign to equal and solve the equation as we did in the previous exercises. In step 3, use the values determined for the previous step to divide number line into intervals. So we'll look then into intervals and see in which intervals the inequality is less than or equal the number on the right side in this case. Yeah, so in step 4 we are testing the intervals for which intervals is the one we are looking for and which one is not. There is a little tip. We can move, for example, in this case, the 5/9 to the left side, so keep the right side equals 0. Then when we are in step 4, when we are testing, we don't really have to do the computation and test if the number is less than 5/9, but we just need to know if it's less than or greater than 0. In other words, is it negative number or positive number? So let's look at the problem now, how we would solve it using the steps. So first steps, what are the excluded values? Well, in this case, there's only one excluded value. X cannot be 0. Yeah, we look at the denominators with x, solve them to equal 0. In this case, we get the same solution. X cannot be 0. Now we want to solve the related equation. So change the inequality sign to equal. And here we change it to equal. And now we solve it the same way as in previous exercises. So least common denominator is 9x. We multiply every term in the equation by 9x. And after that, we just solve the linear equation, get that x equals 15. In step 3, we want to determine the intervals. So we want to split the number line, like we have here, using the numbers from the previous steps. So the excluded value from step 1 was 0, so let's draw it over here. And from step 2, we got 15, so 3, 6, 9, 12, 15. So you got 15 to be another value. So now we split the interval, and we will be in step 4 testing which one of these intervals works for our inequality. But before, let's look at step 3.9 and move 5.9 to the left side. So we get here less than or equal to 0. So we are just checking. That can sometimes help us to just check if the interval is negative or positive. And we don't have to really get the solution. So in step 4, let's start. So let's test the interval on the left. How do we do that? We choose a number less than 0 from the interval on the left. So for example, -4. This is why we, for example, did the step 3.9. Because if I now put negative number for x here, and 5/9 is already negative, then my solution will be also a negative number. In other words, less than 0. So without even doing any computation, I know that this interval works for me. That's the negative interval less than 0, and it's an interval that's suffice our inequality. I did a computation. You can see that you get a negative number -80/9, which is less than 0. Let's go to the middle interval. Now, for example, again, you can try any number between 0 and 15. I tried number 3. So when you put number 3 here, now it's a little bit more complicated because two numbers are positive, one is negative, so we actually have to do a computation. And when you substitute x with 3, you will get 20/9. Well, we get 20/9 is less than 0. The number is positive. We are looking for a negative number. We can see that this inequality is not correct. So we know that the middle interval, since it's positive, doesn't work for our inequality. So this is not, the middle interval is not a solution of our inequality. Let's finish with the right interval. Let's choose, for example, number 18. Again, you can choose any number greater than 15. And if we choose number 18, again, in this case, you can do the computation. But for example, if you just look at it, number 18, will make these two fractions smaller than the -5/9. So it kind of suggests me, okay, this is going to be negative. If you do the computation, you'll actually get -5/9 is less than 0, which works. So this is going to be the solution because this interval, all numbers from this interval will be less than 0, will be negative. So what is the solution then at the end? Well, we checked that the interval or the inequality works for all the numbers less than 0 and all the numbers greater than 15. So we can write a solution that x is less than 0 and x is greater than 15, or in the interval notation from -infinity to 0, you need 15 to positive infinity. Here we have some practice exercises for rational inequalities. So please pause the video, try to work on them, and then the solution will be displayed here on this page in a few seconds. Okay, so let's look at the solution. So for the first one, the excluded value is 0. 0 cannot be in the denominator. After that, when you compute the equation in step 2, the solution should be 11/10. That's what these two numbers you will need to use to split the interval and then test for the different intervals, and you should get to the solution that only the middle interval works for your equation. Therefore the solution is 0 is less than a. That's less than 11/10. Of course, this can be written also as an interval notation, 0 to 11/10. And in another example, so excluded value, we will have more excluded values. In this case, -2 and 1 cannot be in the denominator. After, in step 2, you solve the equation, you will get actually two solutions, since here, because the x here in the numerator, you will get a quadratic equation. You get two solutions, -5 and 2. Therefore, you will split the interval with 4 numbers, the number line with 4 numbers. So you will actually get 5 separate intervals. And now, after you try all the numbers and look for which interval works for you, which interval is less than 3/2 or negative, if you move the 3/2 to the left side, you will get that it works for x less than -5, for x between -2 and 1, and for x greater than 2. Again, this could be also written in an interval with two units.